Hey, welcome. We're surrounded by numbers all the time, and our favorite trick is to just boil everything down to one single number, the average. But what if that average is actually hiding the most interesting part of the story? Today, we're going to look past that single number to find out what our data is really trying to tell us.
Okay, picture this. The clock is ticking down in the championship game. It's all tied up. You've got two players on the bench, and both of them average 20 points per game. I mean, on paper, they're basically the same person. So who do you trust to take that final game-winning shot? It's a nail-biter of a decision, right? Well, what's so cool is that a little bit of statistics can give us a shockingly clear answer.
Because here's the secret. The answer isn't hidden in their average, not at all. It's all about the spread of their performance. Are they consistently hitting right around that 20-point mark, game after game? Or are their scores just all over the map? This idea of spread is absolutely key. And that brings us to the real hero of our story today, variability. That's the fancy word for it. It's just a measure of how scattered or spread out all our data points are. See, the average tells you the center of the story, but variability gives you the whole picture, all the context you were missing. To put it simply, if your data has low variability, all the points are kind of huddled together, nice and tight. But if it has high variability, they're spread far and wide. And getting a feel for this difference is so important, whether you're a basketball coach, a business owner, or really just anyone trying to make sense of the world.
So, how do we actually measure this stuff? Let's start with the most basic tool in the toolbox, the range. It's super simple, it's fast, and it gives you a quick, first-glance idea of what your data looks like.
And the name says it all. You just find the highest number in your data, find the lowest number, and do a little subtraction. That's it. That gap between the two extremes, that's your range.
Let's use a really easy example to see this in action. Here are the daily high temperatures for a random week. You can see they kind of bounce around a bit, but by how much exactly? Well, the range can tell us in a snap.
So we just grabbed the highest temperature, which was 30 degrees, and subtract the lowest, 22 degrees. And there you go. The range is 8 degrees. So this tells us that across the whole week, the temperature swung by a total of 8 degrees from the coolest day to the warmest. Easy, right? But, and this is a big but, that simplicity comes at a price. The range is awesome for a quick peek, but it only pays attention to 2 points, the highest and the lowest. So imagine one freakishly hot day, an outlier. That one day could give you a massive range, even if all the other days were practically identical. It tells you nothing about the data in the middle, and for that, we need a much better tool.
Okay, so to get a more honest look, we need a tool that doesn't just focus on the extremes. And that brings us to our next level up, mean deviation. Now, unlike the range, this one actually considers every single data point and how far it is from the average.
What's so great about this is that we're now figuring out the average distance of every point from the center. You can think of it as a more democratic way of looking at the spread. Every data point gets a voice. This gives us a way better sense of how consistent the data is. All right, check this out. We've got two different classes that took the same math test. You can see right away that Class A scores are all over the place, from a 70 all the way up to a 115. But Class B, their scores are packed together much more tightly. So let's see what the mean deviation has to say. And wow, the results couldn't be clearer. Class A has a mean deviation of 12.5. That means on average, a student's score was 12.5 points away from the class average. Now look at Class B. Their mean deviation is only 5. This tells us, with numbers, what we could already see. The students in Class B performed way more consistently. Their scores are all clustered right around the average. And now it's time to bring out the big guns. This is the most powerful, the most widely used measure of them all, the standard deviation. Seriously, if variability measures for superheroes, this one would be Superman. It's the gold standard in statistics for a very good reason.
So a lot like mean deviation, it's measuring the average distance from the mean. But here's its superpower. It has this clever mathematical trick where it gives more weight to the points that are farther out. This makes it an even more sensitive and precise way to measure the spread.
Okay, I know the calculation looks a little intimidating, but the logic behind it is actually really cool. You find the average, then you see how far each point is from that average, you square those distances, which is the part that really emphasizes the far out ones. Then you average those out, and finally you take the square root to get back to a normal number. But don't worry, every computer and calculator does this for us in less than a second.
So the bottom line is, its biggest strength is its incredible precision. It's really the backbone of almost all modern statistics. Its only real weakness is that, yeah, it's a pain to calculate by hand, but its power is just undeniable.
All right, our toolkit is complete. Let's get back to that basketball court and finally solve this thing. Who are we putting in for that final shot?
Here we go. Here's the actual data from their last 5 games. And yep, they both averaged 20 points, that part's true. But just look at the patterns. Player A is what you'd call a boom or bust player. I mean, sometimes you get 30 points, other times you get 10. Player B, though, is a picture of consistency. Always right around that 20-point mark.
And the standard deviation tells the whole story. Player A has a high standard deviation of 10. That number is screaming that their performance is super variable. You just don't know if you're going to get the 30-point hero or the 10-point dud. It's a total gamble.
But now, look at player B, a standard deviation of just 0.8. Wow, that is an incredibly low number. It's mathematical proof of what our eyes told us. This player is as consistent as they come. With player B, you know exactly what you're going to get.
So the choice is obvious, right? For that one shot that you absolutely have to make, you don't want to gamble. You want the closest thing to a guarantee. You want reliability. And that means you want the player with the low standard deviation. You're putting player B in the game, no question.
And of course, this is about so much more than just basketball. Understanding this idea of variability, of spread, is critical in pretty much every aspect of life. It helps us manage risk, make sure things are high quality, and just generally make better decisions. Just think about it for a second. A business has to understand the variability in its sales to know how much stock to keep on hand. A factory needs extremely low variability to make sure every single product that comes off the line is perfect. Weather forecasters use it to tell us how much the temperature might swing up or down tomorrow. And teachers use it to see if their students have a really solid, consistent grasp of a subject. It's everywhere. So the next time you just hear an average, I want you to stop and ask yourself, what's the story of the spread? From the coffee you drink every morning to the commute you take to work, variability is all around us. And that leaves me with one last question for you to chew on. In your own life, where does consistency, that low standard deviation, matter the most? Thanks for joining me.